everybody, and welcome to another Desk at Ladyada. This is Shay Ada, and this is my EE desk. Usually I'm at my computer desk, but tonight I thought I'd have a little bit of fun because it's Saturday night, and everybody likes to have fun on Saturday. Let's go put together this new kit I just got from Boldport Club. Finally, there's a subscription service for me because I don't really wear that much makeup, and I don't really need that many bath products or meat of the month or ties or socks or whatever, but I will go for Analog Circuit of the Month Club. So this is from Boldport, and I follow him on Twitter, and he makes like really cool looking electronic circuit boards, like very organic looking traces. And so I signed up for this project kit. You don't know what it is before you get it, and it arrived 2 days ago. And I just opened up to make sure that I actually got something. You never know. Because I've been like kind of sad to stream and be like, oh no, I got shipped the wrong thing by accident. But yeah, I got this kit, and it says, welcome to the Boldport Club, project number 1, boldport.com/BP2. And it's got a sticker on the back, it's signed, it's got a schematic, and I thought I'd put this together and maybe even look into this chip, the LM331. I have never used the LM331. I never even heard of it. So we'll look up the data sheet, maybe kind of see what's going on with the circuit. Sounds like fun, Phil?
Yes.
Okay.
Not only is it fun, I had a couple graphics so folks can see. This is the Boldport Club when they're looking at this. You can't see this right now because it's on the screen, but it's the monthly delivery of electronic goodness. As a member of Boldport Club, you'll receive an electronics project every month. Our projects are designed to be engaging, challenging, entertaining, collectible, and to promote exploration and discovery through the use of electronics. So the 3-month membership costs about £49. Inclusive of shipping to wherever you are. You'll also get access to members-only shop and discussion group on Slack. And here is a picture of my favorite programming language is Soldering.
Yeah, that's what it says here. It's written on here. So
Boldport
looks like it was written by hand.
Yeah. So that's that. We have a bunch of cameras. How would you like to start, Ladyada?
Well, let's go to the big overhead.
All right. We're there.
Okay, so I've got my soldering station set up. I've got a hover cam so I can do close-ups. I've got a little vise. I've got my Hacko. I turned it on already, so it's at 750 degrees. Get my sponge wet because I'm into sponge, not into brass sponge. Got some lead-free solder. And then since this is the Robert Pease project, I also brought out my somewhat ragged copy of the Troubleshooting Analog Electronics from Nat Semi. Moment of silence there for Nat Semi, who was acquired. But this is actually a really good book that I read in college, and it's kind of handy. I learned a couple tricks from it. I mean, it's mostly for people who are really doing a lot of intense analog circuit design, not just like transistors in a breadboard, but actually designing the chips themselves. But it's a really great book, and it's kind of the only book on the topic as well. I love the cover. It's Bob Pease, and he's got this circuit, and it's just so insane that his beard is kind of merging with the electronics. But he was a pretty amazing engineer and had a really great video series. National Semi, for quite a few years, had him do like a weekly video series. I don't remember. Maybe it was monthly. I don't remember the name of it, but it was hilarious. People would basically like Ask Engineer. People would write in questions, he'd answer them, and he was always a little bit irreverent. He also had a really good article. I don't remember which magazine it was. Maybe Electronics Weekly or EDN, but it was always like, what's all this fuss about XYZ? Like, what's all this fuss about, linear regulators? And he would talk about that. It was called something like that. I'll look up the exact name of it. Or what's all this band gap about anyways? Or something like that. And every time he had this article that he would write this column, it was kind of an advice column for electronics, he would cover something. And sometimes he'd cover something that wasn't even electronics based. Anyways, very cool. Please read up on him. He's got, I'm sure, a Wikipedia article all about it. But here's the kit itself. Okay, so I'm going to open this up, see what's in it.
You want to go to hover cam?
Yeah, let's go to the hover cam because it's a little bit smaller.
Okay.
Okay, so anti-stat comes with a sticker. We'll put the sticker on the back of the kit. And it's got, okay, now the hardest part is figuring out how to open this. What on earth? I definitely see the electronics trapped inside.
Push it through.
Push, slide. I think this is glued. I kind of feel weird destroying this, but I don't know how else to do it. Okay. So yeah, I think this was glued together. Or I'm not smart enough to understand.
Whatever. How many engineers does it take to open up an engineering kit?
Okay, so
7.
7. Okay, so I actually get 2 circuit boards. That's kind of nice. I guess 1 in case or something. I don't know. So there's 2. And he's got this lovely script here, and it's got all the components even marked out. And it says, my favorite programming language is Solder by Bob Pease. Yeah, he wasn't into soldering. Oh, it's got a ruler on the back and everything. Tells you where to put the LM331, so you don't really need instructions. You just follow along. There's a transistor, bold port, ground, 5 volts. So you can power it either from USB, because there's a little USB jack, or you can connect this up to alligator clips. That's handy. Okay. So I think I've got all the parts here. I'm only make 1. And of course I have to open this all the way. So this is what takes the longest.
I'll throw some questions in there
sure.
as you do this. Do you use a wired sponge or just a watered down sponge?
I like the damp sponge. I mean, like apparently it's better for the tips long term if you use the brass sponge, but I kind of always just used, all my soldering stations always came with a damp sponge, so that's kind of what I use.
Yeah.
And I like it more. I think it gets the tips a little cleaner, but it does cause a little bit of more thermal shock.
Okay.
No, is this going to be live?
And Stonebleed said he or she was at a developer convention today, and there was a lot of Adafruit hardware there. Yay!
Yay! Thank you.
And this person is going
perfect.
to
exactly the right size.
come on our show and tell. Yay!
Okay, cool. Okay, so got this locked and loaded. Not clear which side you put which on, but let's.
And if anyone wants to watch this assembled in VR 360, go to hugvr.com/Adafruit. I believe this would be the first and only live soldering VR 3D show as well.
Okay, so get the LM331. That's easy. Put that in. Okay, now we have to put in the photo transistor, which is, I'm pretty sure, this, because there's a there's a LED. Let's see where the LED goes. The LED is going to go here. So the photo transistor, I actually don't know exactly which is the emitter and which is the collector, but I'm going to guess that the collector is the long lead. A little bit of fun here. Okay, now put some resistors in. Okay, I've got a 10K resistor. Okay, that goes over here. It looks like it's biasing the photo transistor. Okay, that sits nice and flat. And then we've got a 3.3K. Okay, that goes over here. Okay, we've got a, let's see, this is a 330. That looks like it's for the green LED. Okay, maybe I'll start with just soldering. You know what, I'm going to leave this photo transistor out because I can press fit it in, just on the off chance I'm wrong about which is which.
I think my other little light ran out of battery.
Yeah. Does it matter?
No.
Okay.
Nothing matters.
Nothing
matters but soldering this bolt port kit.
Okay. So let's start, I'll start over here. It's interesting, it looks like you can put SMT components in too, like there's little jumpers on the bottom.
My guess is they've managed to put some different levels of delight for all, because this is neat. Like everything about it is neat.
Yeah.
Like, there's interesting things about it. I'm
yeah,
sure
I
there's
think,
some,
I think it is designed to be SMT. There's a little SOT23 thing going on here.
Yeah.
There's like an inductor. Well, there's an antenna. And maybe these are just like fun little symbols. I think they are fun symbols. I don't think they actually
Yeah.
mean
But I think it's one of those things like there's more discovery to be had than just the assembly.
Yeah.
They seem like they're clever people.
Okay.
People from London are often clever.
They're clever. Is this in focus or should I
Yeah, I mean, if you want to try to move it, yeah, there you go.
That's better?
That's
Okay.
better.
The little screen over here is not not so big. Okay, so I'm going to do the LM331 now. Yeah, there's a little op amp symbol on the back. It's up to lies. I mean, there is a comparator inside, I think, but... And there's AC. I don't know. Little graffiti. Okay, get your clippers, and let's clip this up. Okay, like halfway done. Okay, next up there is a 5 kilo ohm potentiometer. Open the legs back out. Looks like it goes kind of like this. There you go. It sort of fits. I'm gonna do this one now because it's got very short legs. And then I'm just holding it underneath. Okay, so that's the potentiometer. Okay. Next up, there's a there's 5. There's 2 capacitors. Let's look at which is one's which. This is 331, so it's the 330 picofarad. So we'll put that in. And then this one is 102, so that's 1 microfarad. That goes over here. Okay. And then these are always kind of hard to read because of the colors. This starts with a blue stripe, so that's 6, and this one starts with a yellow stripe, so that's, I guess that's the 5K. This is definitely going to be the 6.8. Man, I'm so bad at reading 1%. I'm going to multimeter just in case. It's always hard for me to read the contrast. I have like all the 5% memorized, but I never really deal with 1%. Hello? Oh, oops. Put it in the wrong mode. There you go. Okay, yeah, this is the 6.8, so that's right. But I thought 5K started with green, and that's not green. Oh, it's 4.9 something. Oh, I see. It's 4.99. That's why. I was a little confused about that. Okay, so 4.99K goes in here. Okay, and then last up we have a 2N7000. I do not remember the pinout for this, so I'm going to 2N7000. Get the pinout because I don't want to put this in backwards. Lead 1 is the source. Okay, so source, gate, drain, like so. Okay, and then the photo transistor, like I'm like 99% sure that the collector's the long lead, but I'll just leave that till last. Just remember now that 5% resistors only come, if you want a 5K, you actually have to get a 5.1. That's why I'm always used to 5. So green, brown, red, what I'm used to seeing for 5Ks. But I guess it's interesting is, if it's a precision, why go with the precision resistor if it's in series with a potentiometer? The potentiometer is not going to be that precise. It's gonna vibrate. It's gonna move, but there might be a good reason that I don't understand. Okay. Okay, we're getting there. Getting to the promised land. Oh, gotta do this FET. Gotta watch out. There's these little pads near it. Don't want to short to that SMT pad. Okay. Okay, looking good. All right, so let's do the USB. This one's going to be tricky. I guess
can you use the continuity check on your meter to determine the direction of polarity for the photoresistor?
It's a phototransistor, not a photoresistor. Would it? No, because there's two diodes, but they're in opposite directions. I'll just try both ways. I mean, I'm pretty sure it's a standard. I just haven't worked with phototransistors for a bit. It's not a photodiode. I mean, I guess I could put it in current mode, but I don't have current mode on this multimeter. Okay, sweet. Powered, ready. Okay, looking pretty good. So let's clean up a bit here. Just get rid of these cardboard bits, and then little wire bits. I'll put those in the bin later. And the spare PCB, I'll just keep back in this nice holder. Okay, so next up I want to power this. And I'm just going to use my benchtop supply to do so. It's a little loud, so if you're hearing this noise and you're like, hey, what's that noise? It's the benchtop. It's a little loud. Okay. Connect ground. Connect 5 volt. I'm going to current limit this just in case. Okay. Current draw seems okay. And so this LED is on, but now I'm going to put in this phototransistor, and I think it goes this way. It doesn't flash, which makes me... But the LED is on, so that's kind of a good sign. It's incorrectly.
What's the best way to keep a rail from falling out while soldering it?
A rail?
Yeah.
Tape works really well. Okay, what is this? Pretty sure this goes this way, though. Don't see anything. Seems to be on. Well, let's look at it with the scope. Hopefully, the only thing I wasn't completely sure about was this potentiometer. Let me just hit this up. Everything else looks pretty good. Okay. We can investigate some more. Maybe I'll pull up my scope. Whoops.
Oh, you want me to grab that?
Yeah, this little light isn't even on.
Okay. Just in time.
Okay. I just want to investigate. So I'm going to try this. We'll see if this works. This may not work.
Ready the blue smoke puppet and might need to adjust the pot.
Yeah, I don't know. Yeah, this is interesting.
I got to get my green suit on and get ready to...
I don't think I damaged anything. I mean, The one thing that was not super clear was the transistor, but pin 1 is source, and that's definitely what's going on here. LED's in the right way. 330 ohm, 33K, 331, 681, 4.99, 1 microfarad, potentiometer, yeah. I mean, the potentiometer is centered.
Yeah.
Okay, so, but now we get to learn about maybe debugging stuff.
Can you move everything up forward just a little bit?
This way?
That way, towards the wall. Yeah, just, there you go.
Like that?
Yeah, because I have a little discolated thing. There you go.
Yeah, okay. Yeah. All right, so, well, let's see what's going on here. So I'm going to clip onto this ground. Check my 5 volts. Oh. Looks good. And this always needs like kicking, and I kind of don't like that. Sorry. Measure. Okay, great. Yeah, 4.9 volts. And then, according to the data sheet, let's see. We can look at all the pins and see if all the pins are on. Okay, so pin 2 should be 1.9 volts. Check that out. Well, pin 0 is, sorry, pin 1 is current output. Pin 2, did I put this in backwards? You know, I wonder if it goes upside down. Did I put it in upside down? Pin, oh yeah, it's upside down. This is the opposite side you're supposed to solder it to. Wow, yeah, I totally got this wrong. All right. I soldered on top of the outline when I should have soldered.
So you just got to go to the other side.
Yeah, I got to desolder this. Well, well, no, the transistor's fine. All the passives are fine. The LED's okay. Yeah, because I'm used to, like, you solder on top of the components, but it looks like pin 4 is ground, and if this label is supposed to be ground and this pin is supposed to be power, I have pin 1 connected to power. So I don't think I destroyed it. Yeah, I totally put this upside down. Oh well. All right. I'll desolder it.
All right.
Actually, it's a good thing I didn't plug it into power, because this is probably also upside down.
Part 2 of Desk of Ladyada is desoldering.
I know. You didn't think I was going to do desoldering tutorial today.
Yeah.
This is one of the trade-offs of if you're like, I want to not read the instructions and have more fun.
Yeah, well, this is more fun.
More fun is being had. Okay, so.
Do you want me to go to the overhead? Or
yeah. What's the best tools? I'll get my wick.
Okay, so you just need to take the chip out.
Yeah.
And then put it on the other side.
I should have socketed it, but yeah, it's just gonna be fun to do, because it's also hard because this device.
Is it the only thing you need to?
Yeah, if I don't plug in the USB, that's kind of the only thing I need to do. All right, I don't really have all the best tools for this, but let's see what I can do. So my trick is I always add more solder, which is completely counterintuitive, but lets me get my
that's the solder sucker we sell in the store.
Yeah, it's worth all of the $5. Oh man, I don't know. This might end up taking more than. It is notoriously annoying to desolder dips.
Yep. So if you socket a chip, how is that any better?
Well, I could have like fake soldered it onto the top. I only have one of these chips.
Yeah.
Yeah, I don't know if I'm going to be able to do... Well, I mean, I can probably get something kind of going. I've been working so much with SMT that I don't have, like, a lot of the... I kind of, like, forgot my muscle memory for removing dip chips. And it's also a total pain. It's kind of like if you can't get all the soldering the first go, which I can't. I don't know what to do. I mean, I guess I could cut the leads and then just solder from the other side. And hope I didn't break the chip. That's probably my best bet. Actually, I don't have the. At work, I've got like a nice desoldering gun. I've got like super wide tips, but at home, it's kind of like all I got is this stuff. So yeah, maybe I'll just cut it.
All right.
All right. So cut the leads.
And then that
I'm sure the guy who designed this is like totally horrified. They're like, sorry, dude, like it wasn't clear which side to solder onto, so that's what happens. Destroying your lovely creation. Okay, so once you cut the legs off, at least like you can surface solder it on.
Yeah.
I'm actually I should probably just destroy this USB port while I'm at it.
You're just gonna.
Yeah, because it's probably on upside down too. And I have these in the office, so I'll just, yeah, if I really want to plug into USB.
Yeah.
Okay, so this goes on this side. But now it's a little easier, because I can just remove these, I could remove these pins. So I just push them through. And then on the other side, you can pull the pins out. I have desoldered 8 dips. It's actually not that bad. I just don't have all the tools I need for it.
Yeah.
And then I'm actually going to leave a little bit of solder on here because I'm going to
put them on there. Bink.
I'm going to totally like SMT this dip.
Do you want to put this through the pick and place later?
Yeah.
You can fire up the tester.
All right, so this goes on this side. Yeah, I mean, I guess there's an outline here too. Not really clear which side is which, but I'm just going to lay it on top of here. And then we're just going to pretend like nothing happened. And
no one's going to know. It's not
nobody's going to even know.
It's not like we have a live video of this.
It's totally like there, I fixed it. Of soldering. Wait, there's a pin here too. Hold on. I'm going to get rid of all these pins because they're sticking up.
That's why they give you a spare PCB.
Yeah. I didn't get a spare chip though. Okay.
Can you buy these chips?
Yeah, I mean I'm sure they're like 10 cents on DigiKey. Just didn't think to do that. Okay. All right, look, it's like good as new. I mean, unless I totally destroyed this chip, which is possible too.
This is totally okay.
This is totally fine. And if so, I'll just buy another chip. I'm gonna do another surgery. This is great. Nobody's ever gonna notice. I don't know if I've ever done this. Solder chip upside down. Okay, see, look. So you can't even tell.
Nobody knows.
Nobody even knows.
Okay, well now what happens?
You know, there's another thing. I'm used to having the cup traces on the bottom. So I thought this was like you solder from the top because the traces go on the bottom. Okay. So now, well, luckily at least like I didn't plug into USB, which would have been upside down, I'm sure. So I'm going to just plug in 5 volts and ground again. We'll see if this is surviving the experience. Okay. And then I need that. Okay, now I lost my component. Oh, there it is. So the photo transistor, which I still think goes this way. Oh, it looks like it's doing something. So let's go to the scope.
Okay.
I mean, it might not be doing anything, but yeah, it's like when I move my hand over it.
Yeah, I can see it moving.
It does change. Okay, maybe I didn't break it. Yay! Okay. So, wedge that in. Connect to. This goes. Actually, let's just probe onto here. Oh yeah, there's a totally. Yeah. Can you see the frequency change?
Yeah.
Yay! But it's very high. The frequency is very high. I mean, like, I don't think I damaged it, but. Okay, so I'm going to, I'll solder in this component now, since I know that this goes this way, as expected. I'll just kind of let it hang out here. All right, well, we learned some skills today that we were not expecting to.
Well, here's the way I look at it. I mean, we've had hundreds of thousands of customers, and we're always like, hey, you know, how's it possible that they did this? And one of the worst customers, I'll just say, is very experienced engineers. No offense, Ladyada, very experienced engineer, because, you know, there's so much expertise that you have that you're not approaching it like a beginner, or, you know, like, why read the instructions? Who cares? Boom.
Yeah.
And I think it's neat that you can, you know, quickly figure out something, analyze it, fix it, and we're willing to put a live camera on all this.
Okay, so if I, yeah, it looks like it ranges from like 200 kilohertz to like 130 kilohertz or something. Can you see the square wave on the cam? Okay. All right, well, this is a light to frequency converter, and yeah, the LED is flickering.
Good work.
Okay, neat. So what's interesting about this is I wanted to actually probe. This is an RC filter. So yeah, there's an RC, and then you can see how the frequency does change a little bit when I cover the. Let's move this back up. And this goes from 0 to 2/3 volt, 2/3 VCC. All right. Well, I've never used this chip before, so I'm learning a lot. Okay. Well, that's the project. I'm going to keep this handy. There's a little keychain. Let me find where I put that little keychain thing.
Okay. And that's the desk of Ladyada for tonight, right?
Yeah. Hold on. I'm not done. I guess I'll put the keychain through the ground so that keep this handy. All right. Well, it's a project.
You did it. Good work.
Yay. This is project number 1. So I don't know how many I signed up for. Like 4, maybe?
Yeah, all of them.
All of them? Yeah. All right. So it's a project. Maybe you'll be able to purchase this kit after the fact by going to boldport.com. If not, sign up and you can get the remaining kits, I guess. You can like sign up to get more of them. But this is fun. You can read about the LM331. If I hadn't had to spend that time flipping that chip, I'd probably have spent more time on this. But it uses a current reference, which is actually what the the current output, which is connected to the photo transistor, and it compares that against the threshold voltage. Let's see if I can. This has the schematic on it. So the output definitely is pretty simple. It just connects to that driving 2N7000, which turns the LED on and off. And actually what it's doing is not just changing the frequency, but it looks like it's also changing the pulse width. It's kind of like a pulse width modulation a little bit, like the duty cycle. But it looks like the frequency is set by RNC, this RT-RC, so the 6.81K and the 330 picofarads. So that's what sets the this timer. So you saw that sort of sawtoothy wave. And then pin 7 and pin 2, the comparator input, and the current reference. So pin 2 pushes current reference through these basically 10K resistor together, 5K plus 5K pot. And that 2 volts going through there gives you, that 1.9 volt, which appears at the pin 2, also sets the threshold. The voltage goes through, there's a current reference that's divided by the 5 to 10K. That also sets the, pin 2 is set at 1.9 volts. And that's compared against pin 6 and pin 1. So what's interesting is that it looks like when the RC timer flips, some current is injected into this network, and depending on how much current is being pulled through the transistor, I guess it changes the comparison voltage on pin 6 with pin 7. So the more current that gets pulled through here, I guess, the higher the voltage. So that's I guess maybe what sets the duty cycle for the light. But I think the frequency seems like it's mostly set by RC. So I'm not sure. It doesn't look like this gets output anywhere else, but kind of interesting. It's a little bit like a 555 of current, like current motion, and it's got a flip-flop in it because it's got this comparator that basically turns this current on and off. Pin 1, which goes through the photo transistor, gets compared to this 1.9 volts. So actually, I want to look at that really fast. Maybe I'll just quickly connect up. I want to see what is going on at the photo transistor. Here, this is kind of handy. You can just clip onto here. No, it's not lighting up. Why not? Let's see. It's powered. Oh, I think it's just, I have to dim it a little bit. Okay, so I want to see what's going on here. Okay, so this voltage is going up, and then, okay, interesting. I'll have to research what exactly the phototransistor is doing to the circuit. But definitely is pulling current through this 10K, which changes the voltage. Maybe it's actually just changing the comparator voltage, and it's being compared against the 1.9. Doesn't get that high though. All right, well that's Boldport Club project number 1. Great fun for people who don't read the instructions. I learned a lot, mostly reading. Well, that's actually not fun. If I read the instructions, what would the fun be?
That wouldn't be very fun at all.
No.
That wouldn't be a good engineer. You gotta just jump right in and just do it.
Okay. Cool. I hope more people come up with Kit of the Month clubs, because I would sign up for them.
Yeah. Congrats to Boldport. You managed to, You know, normally Ladyada just makes a product that she wants, and then we put it in the store.
Yeah, I rarely buy kits.
Yeah.
Like we bought the Axie Draw, but like.
Yeah.
You know, Evil Man's only comes out with a big project once a year.
We ordered their new. It's called the handwriting bot. That I know that.
Axie Draw.
Yeah, we ordered that.
Yeah, we ordered that one.
And then trying to think of a kit that we built.
Well, we built the Heath kit.
We built the Heath kit. That was a recent one.
That's a rare.
Yeah, that's a weird story.
That's a little weird.
Yeah. Okay.
All right,
that's
it's
your Disc
midnight.
Ladyada. All right, we'll have
turn into a pumpkin.
we'll probably do Colin's show tomorrow.
Okay. Yeah, we'll have more curvy circuits.
Yeah.
To show. All right.
All right. See you later.
Bye.
Boom.